In this lesson, we're going to look at how we can add and subtract rational expressions. In previous lessons, we looked at simplifying rational expressions. Well, first we looked at what a rational expression is. And then we started looking at how we can simplify them by factoring them. That's the key, factoring, and then reducing. We made the right restrictions, of course. Then we moved on to see how we could multiply and divide rational expressions. So the last logical topic for us to explore is what if we want to add and subtract rational expressions? So rational expressions, again, are like fractions. We treat them like fractions, and so probably the best way to think about it is to consider if we were to add two fractions or subtract two fractions, then we would need to get a common denominator, right? When we're multiplying and dividing, no need to get a common denominator, but when we're adding and subtracting, we absolutely do. So we're going to factor first, but only the denominators if we're adding or subtracting, because the reason is when it comes time to add them together, we need to have them in unfactored form so we can collect like terms. So we're just going to factor the denominators, and then we're going to make sure we have a common denominator by getting each factor in each denominator, and then we'll add only the numerators or subtract, as the case may be. So let's take a look at some examples. Oh, and by the way, we have to do restrictions, of course, too. So 1 over x times 1 over y. X and y are different. At least we have to assume they're different. We have to treat them as different things. So a common denominator, you know that one of the easiest ways to get a common denominator is to multiply two denominators together. So if we have one denominator that's x and another denominator that's y, I could multiply them together, and my lowest common denominator from these two would be x times y, right? So I'm just taking the x from the one denominator, the y from the other, multiplying them together. So if I were to do that, if I want to get that common denominator, this first fraction obviously needs to be multiplied by y on the bottom, but I have to multiply by y on the top as well. Otherwise, I'm changing the fraction. And we've seen this technique before. To get the other fraction as a common denominator of x times y, I need to multiply the bottom times x, which means I'm going to have to multiply the top by x as well. This is just times sign here in the middle. I know it's confusing having x's and times signs. But anyway, going to multiply. So when I multiply the top of the first fraction, 1 times y is y, and I have that over xy. If I multiply the top of the second fraction, x times 1 is x, and I have xy in the bottom there. Now that I've got a common denominator, I can add things together, and I just do the numerators. So y plus x is written as y plus x over xy. And that's as far as I can go. I can't simplify it anymore. All I can do is, I could rewrite it so the x comes first if I wanted to, but that's as low as it goes. The only other thing left to do is to write the restriction, and we've done enough of those now, hopefully, that you can see that if x equals 0 or y equals 0, we're going to have division by 0 errors, and therefore x cannot equal 0 and y cannot equal 0. Sometimes, in order to get a common denominator, we don't have to just multiply them together. If I was to multiply these two denominators together, I'd get x cubed. But since x goes into x squared, x is a factor of x squared, I can use x squared as my lowest common denominator. So in this case, all I have to do is multiply the second fraction by x, top and bottom, and then I'll have my common denominator that I need. I seem to stumble over that word denominator a lot. Got to be a little more careful in my speech, I suppose. Anyway, I end up with 4 over x squared. Nothing's changed for the first fraction. 5 times x for the second fraction over x squared. Now I've got the common denominator. And if I bring them together, I've got 4 minus 5x over x squared, which again, I could rearrange to put it in a more standard form of doing the negative 5x plus 4, but in this case, I don't think it's absolutely necessary. And if x equals 0, we're going to have a division by 0 problem, so that's my denominator there. Here's one where we've got binomials on the bottom. And remember, we have to take them as a whole unit. This x minus 3 is taken as a unit. It's a binomial. And x plus 2 is another whole unit. We have to take that as a single unit. So my lowest common denominator in this case is going to be just multiplying these two together. X minus 3 times x plus 2. This is my lowest common denominator here. I could expand that out, but I don't want to. I like to keep it in factored form, so I will. So if I multiply the top and bottom of the first fraction by x plus 2, I'm going to do it a little bit differently this time to save a bit of space. So I still got x over x minus 3 from the original fraction, but I want to add that x plus 2 onto the bottom, don't I? Maybe I could keep the highlighting here. So if I want to get an x plus 2 on the bottom, I need to multiply the top by x plus 2 as well. So the x plus 2 from the second fraction, top and bottom, just like I did before. And I've got 3 over x plus 2 on the denominator of the second fraction. I need to multiply the top and bottom of this one by x minus 3, which was my denominator of my first fraction. Now I've got a common denominator. Now you may sort of wonder about the fact that this one is in the reverse order of this one. That doesn't matter. Order doesn't matter. But if it makes things easier, you can always write them in the same order every time. So I could have written it like this, so that it's more obvious that these are common denominators. Either way, when I bring them together, my common denominator is just the x minus 3 times x plus 2. And then when I add these together, I've got x times x plus 2 plus, just making sure it was a plus, because I saw a minus sign somewhere. I guess the minus was in part B. I never really addressed the fact that this was a minus, but minus works the same as plus as far as bringing them together goes. Anyway, back to this one. It's a plus. And I've got 3 times x minus 3. Now, in this case, in order to simplify, I would expand out the top. Here's another mistake that I really want you to avoid, because it's absolutely wrong. So I'm about to show something that I want you to not do. Do not go x minus 3, x minus 3. Yeah, I can cancel them out. And x plus 2 and x plus 2. That doesn't work, because the numerator is not fully factored. And you know from me hammering this point over and over again that we can't reduce things if they're not factored. So absolutely cannot do that crossing out that I just illustrated, but then quickly undid. What I can do is do distributive law here and here, and then see if I can collect like terms and see if I can simplify it more that way. So I'd get x squared plus 2x plus 3x minus 9, and I'll leave the denominator factored. And I can collect my like terms, x squared plus 5x minus 9 over x minus 3 times x plus 2. And it's possible that I could factor the top, and if I could, then I could reduce. That's rarely the case that that's possible, and I don't see any factors. 9, the only factors of that are 1 times 9 and 3 times 3, neither of which is going to give me 5 in the middle. So I'm going to no, I can't factor the top. I can write the restrictions, though. If x equals 3, we've got a problem, and if x equals negative 2. Either one of those is going to give me 0 on the denominator, meaning that I am going to be have division by 0 error. And number in part D, again, here's one where our lowest common denominator is already there. the lowest common denominator in this case is x times, why am I putting it in brackets? I don't need to put it in brackets. I don't have to not put it in brackets, but anyway, x times x minus 3. So all I have to do is add to this second fraction, x minus 3, and I'm good to go. And in fact, just to be a little lazy, I'll just add it on right now. If I put an x minus 3 here and an x minus 3 here, well, look at that. Now I've got a common denominator, and I haven't really broken any of the rules. When I bring them together, I'd have 6 minus 3 times x minus 3, because this one is a negative minus. I'm going to leave it as x over x minus 3 on the bottom, but again, I'm going to expand, and I'm going to collect like terms on the top. So 6 minus 3x plus 9, right? Again, I'm multiplying negative 3 times both the terms, and the negative is getting multiplied as part of it. And on the bottom, I've got x and x minus 3. When I collect the like terms, I will put the x term first because that is good form. 6 plus 9 is 15. I've got x minus 3. Now, can I factor? I guess I can factor in this case. I can take out negative 3 as a common factor on the top, and I'm left with x minus 5 on the top. But even that I can't reduce, right? I could leave it. It's good to factor if possible, so I can see if I could reduce, but I couldn't in that case, so I'll have to leave it like that. And my restrictions, x can't equal 0 from this x here, and x can't equal positive 3 from that one. So those are my restrictions there. So that's the basics for simplifying addition and subtraction of rationals. This last few examples are just some ones that require a bit more factoring. So in each of these cases, I'm going to have to factor the denominator first. So x over, let's see, common factor, I can take 4 out, x plus 4, and the common factor for this one, I could take 5 out, and I've got x plus 4. So again, I only need to get my lowest common denominator. All I have to do is get what's missing. So I don't need to repeat the x plus 4 twice, but I do have to focus on the 4 and the 5, some number that both 4 and 5 go into. And 20 would be it. I haven't given myself much room here on the left to do my LCD like I normally do, but my lowest common denominator is going to be 4 times 5 times the x plus 4, because both denominators would go into those. So there's the 4, and maybe I'll color the 5 green. So there's the 4 and the 5, and then the x plus 4 is already in both of them, so I don't need to do it twice, just once is enough. So my lowest common denominator, in factored form, I can multiply the 4 times 5 together, would be 20x plus 4. So the way I'm going to turn that into 20x plus 4 in the first fraction is I'm going to multiply top and bottom times 5, right? 5 times this 4 gives me a 20 on the bottom. But I have to multiply the top by 5 as well, so that gives me 5x. I have to multiply, whoops, not that. I have to multiply this by 4 because that's what's going to give me a 20 on the bottom. So I'll have 20x plus 4 again, my common denominator. Multiply the top by 4, and I've got 20. Bring them together, 5x plus 20 over 20 times x plus 4 with my common denominator. Simplify the top. In this case, 5 comes out. I got x plus 4. And here is a case where once I've simplified the top, I do have a factor that I can reduce, right? This x plus 4 can be reduced in the top and the bottom. Before I reduce it, I'm going to do my restrictions. X cannot equal negative 4. But as far as reducing goes, these cancel out. I'm left with 5 over 20, which reduces to 1/4. So I can also reduce these guys here. 5 goes into itself once and into 24 times. So my answer is 1/4. Maybe I'll put a circle around my answer here and my restriction there just so they stand out a bit more. For B part, again, factor the denominator first. So y minus 4 times y plus 4. And for the second fraction, clearly what I'm missing is the y minus 4 here. So if I do add a y minus 4 to the top and bottom of this second fraction, leaving the 3 on the top and the y plus 4 on the bottom, now I've got a common denominator. I know I did the one factor in red, but that's just to show that that's what I was adding at that stage. But it's a common denominator. So I've got 6y minus 3 times y minus 4 over y minus 4 times y plus 4. And again, use distributive law to expand out. So I'm going to multiply everything by -3, and what I've got is 6y minus 3y plus 12 over y minus 4 times y plus 4, which simplifies to 3y plus 12 over y minus 4 times y plus 4. I can factor the top. So I've got 3 times y plus 4. And again, this happens to be one where I can actually reduce because I have a common factor on the top and the bottom. First, the restrictions. Y cannot equal 4 or -4. And as far as the reducing goes, y plus 4 can cancel out from each one of these. So that leaves me with 3 over y plus 4, sorry, y minus 4, which can't be reduced any farther. And the last one, now we've got a trinomial. Just the same thing going on, though. We got to factor it. So maybe I'll begin by just doing some rough work for the factoring over here. Let's do it in blue, though. That's my go-to color. So factoring the denominator here, 2x times 1x would give me 2x squared. If I did 3 and 2, that's going to give me 6, and I think it'll work out for the middle term as well. What I'll get is 4x and 3x, which if I make the 4x negative, adds to give me -x here. So if I backtrack from that, the -4x would come from making the 2 negative, and then the 3 is positive. So there's my factored form. So I'd have 2 over 2x plus 3 and x minus 2. And as far as the second fraction goes, it's just difference of squares, so it's x minus 2 and x plus 2. So in this case, we've already got x minus 2 in each of these denominators. But I need to have a 2x plus 3 in both denominators, and I need to have an x plus 2 also in both denominators. So whatever's missing from one denominator, I'll add to the other one while at the same time adding it to the top. So I've already got 2x plus 3 and x minus 2. I'm going to add an x plus 2 to this denominator, right? Let's keep going with the colors to show where everything was coming from. I added an x plus 2 to the first denominator, which means I have to add an x plus 2 to the first numerator. For the second one, I'm going to rearrange the order a bit. I'll keep the 3 on the top. I'm going to put the 2x plus, so I don't have a 2x. No, I will. All right, so I'm going to add a 2x plus 2. Let's do it this way, 2x plus 3 to this denominator, which means I need to add a 2x plus 3 to the top. And I've already got the x minus 2 and the x plus 2 there. So I don't need to add anything else to this one. And so now I've got my common denominator. Bring everything together. So that means just adding or subtracting the tops in this case. writing them all over as a single fraction with all three factors in the denominator. Doing distributive law here and here. And so on the top, I would get 2x plus 4 minus 6x minus 9. That's from doing -3 times each of these. Over, again, my same three factors. And collecting like terms gives me -4x minus 5 over 2x plus 3x minus 2x plus 2. And I can't reduce that any farther. There's no common factor or any kind of factoring I can do on the top, so I think that's done. But what I can do is write my restrictions. What I need to do is write my restrictions. If I set the first factor, 2x plus 3 equal to 0, and solve it, I'd get -3 over 2. And then from the second factor, I can't have it be 2, and from the third factor, I can't let x equal -2. So those are my restrictions that are going to cause division by 0 errors. And so that's the most complicated one, where I had to factor trinomials and differences of squares and multiply and distributive law and bring like terms together and so on. But it's all going back to following the basic rules of adding and subtracting fractions, which you've learned in the past.